By nature, JavaScript is a dynamically typed language. That means that, for example, you can declare a variable and assign a string to it, and a few lines after that, you can assign a number to the same variable. There are some other unpredictable or odd behaviors, like doing math operations between numbers and strings. So in a large JavaScript code base, that may cause problems, even more so if multiple developers are working on the same code base. In a nutshell, TypeScript adds static type support to JavaScript, making it less error-prone and a more predictable language. So what is TypeScript? TypeScript is a typed superset of JavaScript. It is JavaScript plus static type support, is built by Microsoft. It compiles or transpiles to plain JavaScript. It supports up to ECMAScript 6 and future proposals like async functions. And for small projects, it may add unnecessary overhead. So if you are working by yourself in a small JavaScript project, it's probably not a good fit for that. When we say that TypeScript compiles into JavaScript, here we have an example of that. On the left side of the screen, we can see an enum type, and on the right side, we can see the JavaScript code that is the result of transpiling the TypeScript code into JavaScript. So why should you use TypeScript? TypeScript enables static type checking. So static typing is a feature that detects bugs as developers write the scripts. So the differences between static type checking and dynamic type checking matter most when a type error occurs. In a statically typed language, such as Java or C#, type errors occur at compile time. In a dynamically typed language, the errors occur only once the program is executed, so they occur in runtime. This means that a program written in JavaScript can compile even if it contains type errors that would otherwise prevent the script from running properly. On the other hand, if a program written using static types contains type errors, it will fail to compile until the errors have been fixed, and this is the case of TypeScript. There are some other benefits, such as refactoring with TypeScript tools. This is easier and faster. And if you're using a wrong type, the IDE will let you know. TypeScript improves readability and maintainability. Types are one of the best forms of documentations that you can have. TypeScript enables code completion and IntelliSense, and TypeScript code, or the application written using TypeScript code, tend to be less error-prone. These are the basic types in TypeScript. We have Boolean, number, string, array, tuple, enum, any, void, null and undefined, never, and object. So we are going to see these basic types in a few seconds. So remember to subscribe to the channel, and let's get started. Okay, let's get started by installing TypeScript in our local environment. So npm install, I'm going to install TypeScript globally. So I'm going to use minus G for that. Okay, and now we are able to transpile using TSC, the TSC command, and the name of the TypeScript file. In this case, it's going to be test.ts. So this is going to transpile into a JavaScript file that now is going to be empty. Let's get started by using Booleans. This is one of the basic types. So let's say let is okay. And here we declare the type Boolean equals to true, for example. Let's say that I want to assign a value of a different type. So let's say is okay, and I assign a string to it. It's not going to allow me because the type string is not assignable to a Boolean. So we declare a Boolean here, so the only thing that we can assign is a Boolean. The same happens if I assign a number, for example. I'm gonna get the same error. Okay, so let's move on to numbers. For numbers, we can say let count colon space and the type. That is, in this case, is number, and we assign a value to it. We have two ways of declaring types, explicitly and implicitly. This is the explicit way of assigning a type to a variable, but the implicit way is, for example, if we declare this count variable and we assign a number to it, I cannot assign a value of a different type. So let's say if I assign a string to it, I'm gonna get an error, because this string is not assignable to a type number, that is the one that is implicitly or inferred here. And the same happens if I assign a Boolean, for example, I'm gonna get the same error. Okay, let's undo this and let's keep the type there. Okay, let's move on to strings. So let name of type string equals to John. Okay, so the same happens here. If I assign a number to this string, I'm gonna get an error that the type of 1 is not assignable to the type string that I already declared on line 12. And the same for Booleans and strings. And here I can use the same things that I use in JavaScript. For example, backticks, I can use template strings, so that doesn't change. As I said in the presentation at the beginning of the video, TypeScript is JavaScript, but with strong typing. Okay, let's move on to arrays. So let's say that I want to create an array of numbers. I can declare something like number, and I can assign a value to it, like 1, 2, and 3. And let's say that I want to add a string value as part of this array. I'm gonna get an error because it was declared as a number array. So I cannot assign strings as part of this array. And another way to declare arrays is doing something like this. Let my list, and I can use array, and here I can declare the type. Let's use a different one. Let's use Boolean, for example. And here I can assign, I can assign the values true, false, and if I assign a number, for example, I'm gonna get an error because this array is a Boolean array. Okay, let's move on to another type that is called tuple. So using tuples, I can create pair of values. So let's say let pair, and I can declare the type like this. I can say that this pair is going to be defined using a Boolean and a number. So I can assign values to it. like this. I can say true and 1, for example. But if I want to assign, let's say, a string and a number, this is going to throw an error because the first element of the pair or the tuple expects a Boolean, as we declared here. Okay, so I'm going to remove this, and let's compile, or let's transpile this TypeScript code, and let's see what we get in the JavaScript file. So if I go to the JavaScript file, I get var instead of let, the same for the numbers, string. In the array, I get basically the arrays as usual, and the pair, I get an array with 2 elements. That's pretty much how JavaScript represents that tuple, with an array with 2 elements. Okay. Moving on to the next basic type, we have enums. Enums are really, really cool. So let's say that we define enum cities. So here, we can say Paris, Barcelona, London. And we can declare a variable using that enum. Let's say let Paris of type cities, and we assign the value, cities that Paris. Okay, let's transpile this, and we're gonna see that the code that we get in JavaScript is quite different to this. So basically it creates a variable, a function, it assigns an ordinal number to each value, it assigns a string to each value. So it's really different from what we defined it here. Moving on to another type. This is a special type. It's like not using types at all, but at least is explicitly saying that you can assign anything to the variable. It's like in JavaScript you can assign any type because it's a dynamically typed language, but in this case you are saying, okay, this variable specifically is going to allow any type to be assigned to it. So we can say that, so we can declare an any variable like this, let any var equals, and here we declare the type any, and here we can assign a number, and we can assign, I don't know, a string, we can assign an object, typo here, anywhere. Okay, we can assign any type of value or values of any type. Let's see a new type called void. So the difference with any is that with any you assign a type, but with void is the opposite, because it's the absence of having any type at all. So for example, we can use a function show message, and we say that this is a void function because we don't return anything. So we can, let's say, console log a message. So in this case, void is the absence of any type at all. Okay, let's move on to null. So we can define a variable let null bar of type null, and the only thing that we can assign to it is null. If let me move this a little bit. If I assign, I don't know, a number to it, it's going to throw an error. It's going to say that the type of one of the value that I'm assigning is not assignable because I declare here that is a null variable. So I cannot assign numbers, I cannot assign strings or Booleans. The only thing that I can assign is a null value. Okay, and let's see another type that is undefined. Undefined. Let undefined bar equals, colon undefined, and we can assign the value undefined. Undefined, like that. And this is pretty similar to null. So you can say undefined bar equals to 1. It's going to throw out an error because you can only assign the value undefined to it. Let's move on to some other special type that is part of the basic types in TypeScript. That is called never. And you can use it, for example, for a function that throws an error, for example. You can use for that, or you can use it for a function that never returns a value, or a function that never ends, for example. So let's see where we can use never using some functions. For example, we can say that function error, where we can pass a message. Let's say that it's going to be a string. And here we say never. We assign that type to this function, and within it we throw a new error. In that case, we can use never. That's an explicit way to assign never to the function. There is an implicit way, or an inferred way, to instantiate this. Function fail return error, and we pass the message here. In this case, it infers never as the type returned by this function. And the other case is, for example, if we have a function with an infinite loop within it, like this. Function infinite loop. And let's say that you have a while with a constant as condition. So this will never end. So this has an unreachable endpoint. That's why we can declare the return type of this function as never. Let's move on to another type. This is object. So let's say that we have a function create that receives a param of type object. And we return that object. So let's say that I want to call this function using a string. I'm going to get an error because it expects an object as an argument. So if we pass an object, and then the object is fine. If we pass name John, that is fine. And let's say that we pass, I don't know, a number, we get an error. There is a special structure provided by TypeScript where we can assign different types to the same variable. So in this case, we can assign that this argument could be an object or a number. So in that case, we don't get any errors here. Or we can add, I don't know, we can pass a Boolean. And here we can say create, and we can pass true as a parameter. So if I remove number, I'm gonna get an error here because now it won't allow me to pass a number as an argument. Okay guys, for the first part of the TypeScript crash course, now we know what are the basic types provided by TypeScript. We have Booleans, we have numbers, strings, arrays, tuples, enums, any, void, null, undefined, never, and object. Okay, for the second part of the TypeScript crash course, we're gonna see things like interfaces and custom types. So I see you guys in the next video. Take care. Bye.